is less strong. According to experts, fiberglass is stronger than steel for the same weight. Hence, there is no issue in choice of material, but the main factor remains to be the design model and how it's tailored for each material. Generally, capsizing results from insufficient initial stability, lack of operational stability, and more often, a combination of both. Contributing factors for capsizing are raising the vessel's center of gravity beyond a critical point, water flooding down through open doors, hatches, or flush deck fittings, free movement of water in the hold or in tank that is only partially filled, boat's incapability to handle and satisfy passenger crowding. Understanding and managing the stability of a vessel is critical to the safety of the vessel and the crew itself. Planning for stability should start from the initial design stage of a boat.
For the safe operation of a boat, one of the most important aspects that has to be studied is the stability of the boat. The stability of the boat has to be estimated in the very preliminary stage, that is in the design stage itself. In the design stage itself, the naval architect has to conduct a very preliminary study of the stability of the boat and ensure that the boat will be stable after its construction. For this purpose, the naval architect has to estimate initially itself what would the weight of the boat be, what would be its center of gravity, and initially itself have a check whether the stability is satisfactory. How do you check whether the stability is satisfactory? The stability check is carried out based on internationally accepted criteria which has been laid out by organizations like International Maritime Organization or the IMO, which is supported by various third-party approval authorities like the classification societies like Indian Register of Shipping, the IRS, the American Bureau of Shipping, ABS, or the Bureau Veritas, which is a French classification society.
The basic parameters required for boat design are loading capacity and configuration, operational environment including speed, wind, and waves, endurance, how long the maximum voyage time should be. These basic parameters are considered complying if and only if the stability of the boat is met with the owner's requirements.
Once the vessel's construction is completed, we have to conduct an inclining experiment which can be simply called a stability test. The stability test is normally conducted by a naval architect, and the results of this stability test gives us the weight of the boat and its center of gravity after construction. So this inclining experiment has to be conducted after the vessel is floating and after all the complete construction of the boat has been completed. And this experiment has to be conducted normally in presence of one accepted third-party company like IRS or the ABS or the Lloyd's Register or Bureau Veritas, who are approved and internationally approved for approving these stability tests and results. And once the inclining experiment is conducted, using the results of the inclining experiment, we can prepare a stability booklet. The results of the inclining experiment, which are basically the weight of the boat, the center of gravity of the boat, once these are calculated, we can use these values to calculate the stability booklet, to calculate the stability conditions of the vessel and check whether the vessel has satisfactory stability or not.
The boat should be completely set to overcome any casualty in case of any emergency or unforeseen circumstances. This includes sufficient life jackets for all on board, a safety briefing before the trip, life buoys and life rafts based on number of passengers on board, basic first aid kit, hand flares, fire extinguishers, emergency exits clearly marked and two means of contacting shore for communication with a list of emergency contact persons and numbers pasted on board. Basic designs formulate the foundation of any substance, be it in a building or a vessel. But if the design is faulty, no substance can withhold its existence, and it definitely tends to crumble down. Something of similar nature has happened with our ill-fated boat. According to our experts, it's the basic foundation of the boat which had loopholes in it. It's surprising thing to note that the overall faulty boat still stayed afloat in spite of the various tests that were not done. Let's hear from our experts regarding the conclusion on the design and the overall faults that they have deciphered from the ill-fated boat.
The main failure was that there was no naval architect involved in this project, right from the tendering stage till the handing over the vessel. So if a naval architect had been there, he would have definitely been cautious about the stability of this vessel. He would have conducted an inclining, he would have insisted on conducting an inclining experiment, a stability booklet, a stability certificate. All these things would have taken place automatically. Now the builder has made substantial changes on the design while he built the vessel, but this is quite normal. But he should have taken the advice of the designer while making these modifications. For example, there was a staircase in the middle, and this staircase was weighing maybe around 150-160 kilos. This was shifted over to the starboard side, and simultaneously he put a bilge pump on the starboard side, and there were changes in the seating arrangements which led to an imbalance of weight of 351 kilos to the starboard side. Now this led to an inherent angle of a list of the vessel, 2.1 degrees to the starboard side. Now in order to compensate that, what he did, he put 3 seats on the upper deck on the port side. Major mistake of his was, there was a clause in the building contract saying that he should have a stability certificate from the IRS. Now he did not ask the IRS for a stability certificate. So he did not ask the designer, he did not tell the designer about this. So designer did not make any stability information booklet, and this was not sent to the IRS for approval. And eventually what happened was the total stability of the vessel was ignored. As per the hull certificate, all the hatch openings on this vessel should have been closed weather tight. It is written in their own rule book. But there was a big hatch opening. There were 5 hatch openings on the vessel, but none of these hatch openings were weather tight by giving nut and bolt. But what exactly happened was, there was a big hatch opening on the middle of the boat. On both sides, people were sitting. So when the boat heeled 90 degrees, this hatch opening opened, this hatch cover opened, and the people sitting on the port side fell into the engine room. And when the boat took a 180 degree turn, due to the hydrostatic pressure, this hatch cover came and closed again. So let's take, he's fully loaded, 75 passengers sitting. His calculation shows that the angle of heel is only 8.5 degrees. But after doing the inclining experiment, this angle of heel is 14.51 degrees with 75 people sitting, crowding of passengers on one side. That means, if on the starboard side or port side, all people are sitting, and the people on the other side, if they just stand and come into the middle, the vessel will have 14.51 degrees, and at that particular moment, all the people will lose their balance. They will be thrown to the starboard side, and due to that momentum, the boat will be tilted 180 degrees. This is exactly what happened.
According to researchers, the ill-fated boat was faulty from the very start. The boat was not properly insured, nor did it have any basic fitness certificate which could let her float in the calm back waters. In spite of this, the owners of the boat knowingly put so many lives at stake. In the wake of the incident, it has also been noted that the designer himself didn't monitor the building of the boat. The small fault was even neglected by the authorities who came in to certify the vessel, which finally resulted in endangering many innocent lives that came down for a pleasure trip. The owners of the boat even allowed more than regular passengers that the boat could actually handle. Still, it is being observed that none of the safety measures are being followed in any of the boats which are floating. Is it sheer negligence, or has the value of human life started depreciating? By compiling the various facts and figures, it leaves no one away from the fault. From the owner to the designer to the class operator, everyone has a clean role to play in this incident, which has claimed many lives. The link cannot be overviewed, but precautions are meant to be taken. This incident is a wake-up call for all the authorities who neglect mere factors which can cause extreme consequences. Whatever be the reason, the grim reality is that many innocent lives met with a watery grave at the enchanted lake of Thekkady. It's high time for us to act, as prevention is always better than cure. Will this incident prove to be an eye-opener, not only to boat owners but for policymakers? There is an urgent need to subject the boats plying on our lakes, backwaters and coastal waters to stringent checks and regular maintenance. This is of paramount importance in respect of boats that operate in the tourism sector.
There are certain messages I want to give to the naval architecture community, especially for the classification society.